Hello students, Assalamu alaikum. Now today we are going to do quadratic functions. This is my lecture number 4 on SATs. So we are going to discuss quadratic functions. So if we have a function that is quadratic of this form ax square plus bx plus c. This is known as its standard form, right? And if it is written in this form ax minus h whole square plus k, this is known as invertex form, and third one is the factored form. These are three formats of a quadratic function. Now there are some basic things what we should know. Finding line of symmetry and coordinates of vertex. So generally if we have a quadratic curve, okay, may it be like this. If we have a quadratic curve like this, so this is the quadratic curve. Now in this quadratic curve, if you see, this is known as, this point is known as vertex. Okay, this is your vertex, and a line that divides it into two complete parts is known as its line of symmetry. So this is the line that is passing through vertex and dividing it into two equal halves. Okay, so this is the line of symmetry. So we call it line of symmetry. Line of symmetry. Okay, so it is very important for us to it's very important for us to understand that how we are going to find equation of line of symmetry and coordinates of vertex. So in all these three cases it's different. For example, if we discuss first standard form, so have a look. In standard form, when we write equation in this form, f of x or y equals to ax square plus bx plus c. Now equation of line of symmetry is, line of symmetry is going to be x is equal to minus b divided by 2a. Now this is a and this is b, so line of symmetry is equal to minus b divided by 2a. Okay, and coordinates of vertex, is going to be, this is the vertex. Okay, now x is equal to minus b divided by 2a, so line of symmetry, and coordinates of vertex are going to be, x coordinate is minus b divided by 2a, the one with line of symmetry, and f of minus b divided by 2a. Now what does it mean? It means that you're going to substitute this value of x, whatever you get, in original equation to find out coordinates of the vertex. Okay, so let's discuss how it works. So for example, we have equation of a quadratic curve, maybe x square minus 6x plus 8, right? So now value of a is 1, b is this, and c is this. So we know that equation of line of symmetry is going to be, equation of line of symmetry is going to be x is equal to minus b divided by 2a. So minus b divided by 2a, x equals to minus b divided by 2a, that makes it 6 divided by 2, that is equal to 3. So line of symmetry that divides this graph into two equal halves is x equals to 3. And similarly, if we need to find y coordinate of vertex, line of symmetry also represent x coordinate of the vertex. Okay, so now for vertex, we know that we are going to substitute this value of x in original equation, that is given us y equals to x square minus 6x plus 8, right? So x equals to 3, so y is equal to 3 square minus 6 into 3 plus 8. So it's 9 minus 18 plus 8, that makes it 17 minus 18 and y equals to -1. So your vertex is 3 and -1, and line of symmetry is x is equal to 3. So I hope it's clear. This is how we find equation of line of symmetry and vertex, okay, if it is in standard form. The second one is the vertex form. So if it is given in the vertex form, number 2 is vertex form. So if it is given in vertex form, that makes it f of x is equal to a x minus h square plus k. So first of all, when we have to find its line of symmetry, so its line of symmetry is going to be, you're going to substitute this equal to 0. So x minus h equals to 0. So you get it by doing x is equal to h. And second one is your vertex. Your vertex are the coordinates h and k. That's pretty easy. Okay. So if we have a curve like this, so its line of symmetry is x is equal to h, and coordinates of vertex are going to be h and k. Okay. Third one is, if we have number 3, if we have expression, quadratic expression or equation given in factored form, that is given in factored form. So if it is given in factored form is f of x is equal to a x minus x1 x minus x2. So this basically means that if you have this situation, this is your x1 and this is your x2. Now obviously your line of symmetry is a line that divides the whole graph into exactly 2 points, and it is passing through middle of the curve. Okay, it divides the curve into 2 parts. So this is middle of these x1 and x2. So we say that line of symmetry is given by line of symmetry is given by x is equal to x1 plus x2 divided by 2. By doing so, we get equation of line of symmetry. And for vertex, we substitute this value back into original equation. So for vertex, x1 plus x2 divided by 2, and f of x1 plus x2 divided by 2, right? So this is how we find coordinates of the vertex in all these 3 formats: vertex and line of symmetry. So now let's solve questions related to quadratic. In my first question, question 1 and 2 refer to the following. So h is equal to, it's a quadratic, height is given as a quadratic function of t, minus 16 t square plus 256 t plus 0. Okay. A ball is thrown straight up from a ground with an initial velocity of 256 feet per second. The equation above describes the height of the ball that reaches in t seconds. If the ball reaches its maximum height in k seconds, what is the value of k? Now, it's a quadratic curve, leading coefficient is having negative value. So this is going to be such kind of curve. Okay. And you need to find k. Basically, when ball is at its maximum height, so basically they are finding x coordinate of the vertex, or you can say this is line of symmetry. So line of symmetry, you can say x is equal to minus b divided by 2a. So that is equal to 256 divided by 32. 3 8s are 22. So that is equal to 8. So k is 8. You could say in 8 seconds, ball will be at its maximum height. So your answer is option A. Okay. And in second part, what is the maximum height in feet of the ball will reach? So you have x is equal to 8. You go back to the original equation and substitute h equals to 8. So 256 into 8 minus 16 into 8 square. So that's going to be 1024. That is option C for this. Okay. Next part says, okay, now this is in factored form. If the function above has vertex h and k in xy plane, what is the value of k? It is recommended you draw a rough sketch of it. Okay, so h and k. Now you see leading coefficient x square would be positive, and if you write its corresponding equation and put it equal to 0, we have two values of x, that is equal to minus 2 and 10. So that is equal to minus 2 and 10. Your quadratic curve is like this. Okay, and this is h and k. What is the value of k? You basically need to find y coordinate of this. So first of all, minus 2 and 10. So the equation of line of symmetry or x coordinate is going to be minus 2 and 10 divided by 2, that is equal to 8 by 2, that is equal to 4. So x is equal to 4 is the line of symmetry, but we need y coordinate here. It's 4, and you go back to put 4 in original equation. So y is equal to half 4 plus 2, 4 minus 10, that is equal to 1 by 2, it's 6 into minus 6. So that makes it minus 18, right? So next question is y equals to 3x square minus 6x plus 10. I want you to stop the video and try to solve it yourself. Okay, done. So y equals to 3x square minus 6x plus 10. You need to complete square it. Y equals to, you can take 3 common out of it. That makes it x square minus 2x plus 10. And you can write it as x minus 1 whole square minus 1 plus 10. And this is going to be 3x minus 1 whole square minus 3 plus 10. That is 3x minus 1 whole square plus 7. So 3x minus 1 whole square is B, the answer for this part. Okay, and yes, now this part is it says y equals to ax square plus bx plus c is shown in the xy plane above, where a, b and c are constant. Which of the following must be true? So for sure it is opening downward. So we know that curves, quadratic curves, ax square, if a is positive, that's opening upward, and if your a is negative, coefficient of x square is negative, it's opening downwards. So if it is opening downward, a is negative. Okay, this is for sure is true. Second part, they say c is the y-intercept of the curve, of any curve, so c is positive, so this is not true. The only thing left is questionable is b. So b is basically x is equal to minus b divided by 2a. Now listen, your line of symmetry is for sure positive. Your line of symmetry is for sure, here it is x is equal to minus, this whole thing should be positive. A is already given as negative, so if a is negative, that will balance this minus, so b has to be positive. Okay, so 1 and 2 only, so 1 and 2 only are the best answer for this, right? And at the end, question number 6, it says we have a function f of x equals a x minus h whole square plus k. Now listen carefully. It says the function is defined by the equation above, where a, h and k are constants. If a and k are negative, which of the following cannot be true? Hold on. If they say a is negative, that means it's opening downward, and k is negative, that means your vertex is h and k. That is for sure negative. That is lying below x-axis. Okay. A is negative, it's opening downward. We discussed this thing here. If your leading coefficient in quadratic curve, if it is negative, that means it's opening downward, right? So if a and k are negative, which of the following cannot be true? So f of 5 is less than 0. So that's pretty obvious it can be, okay? So this is like not the answer. F of 5 is less than 0. F of minus 5, suppose minus 5 is here, that is less than 0. That is pretty obvious, that can be true. F of 1 is k. Yes, it can be. F of 1 is equal to k because k itself is a negative entity. So this can be true. F of 0 minus k, you see k is negative. So if minus times any negative value will become positive. So it's not possible to have minus k that will eventually give you value here, give us a value here. So f of 0 is equal to minus k. It's not possible. Other three are possible, can be. So D is your answer when they say this is not possible. That cannot be true. Okay, so this is how it works, how we discuss quadratics in SATs mostly. Okay.